I'm going to just talk to you about some recent cyber attacks, so get out your bingo cards, which is really the motivation behind why we're doing this work. I'll describe a little bit about the smart grid environment that we're using as the test case for the project. I'll talk about a multi-stage cyber attack, which we'll show you upstairs. BooJoong will then tell you about the intrusion detection system that we've been developing for that smart grid environment, and then we'll take you up to the lab. So, bingo cards at the ready. A brief overview of recent attacks that we think are kind of motivating our work and which may be relevant to the kind of systems that are being developed by the guys at AIT for photovoltaic installations. So, in 2014, it was found that black energy was appearing on some HMIs that were internet facing. It's thought potentially they were there from 2011, so I'm not sure that there was any evidence of actual malicious activity going on, but the malware was found there on those internet-facing systems. So the HMI products maybe shouldn't have been connected to the internet, but it definitely seems that GE, Siemens, Broadwind, certain vendors were being specifically targeted. In 2014 then, the HAVX remote access Trojan was found on a number of control systems. So particularly some of these seem to focus on smart grids, so wind turbines. There's also some discussion about whether they were found on pharmaceutical installations. So as with many of these things, information isn't all out there. But what seems to be known is that basically there were watering hole attacks where vendor software was infected at the vendor's website with the HAVX Trojan. So customers of that vendor were then using that what appeared to be legitimate software, installing it on their systems and giving backdoor access to those systems to the perpetrators. So basically HAVX allowed the controllers of the remote access tool to scan for various things to do with OPC communications. So OPC is a Microsoft-based communication setup for industrial control systems. So it was shown to be scanning for specific OPC servers, OPC-related stuff, so it was definitely targeting ICS systems in some way. Again, it's not clear if or what damage would have been caused, but it did seem to be targeted in some way at those systems. So I've talked about aRAT. So what is aRAT? So depending on how you want to look at the acronym, it's a remote access Trojan or remote administrator tool. So the one you'll see upstairs in the lab is basically very friendly, very nice GUI, kind of everything's easy to click. It's like something you'd use from a professional tool. So it's ridiculous how easy these things are once you have them. So there are lots of these out there. So the one that we're using, we'll show you, is Dark Comet. So we have previously done demonstration activities. So we had a workshop similar to this in Cork last year. So the tool we used for that was PlugX. So that's this one here. So it has some Chinese characters. So without wanting to offend Chinese people here, maybe that scares some people. Foreign nations are involved. But that tool, we used it. We infected a PDF with it. So you open the PDF, you click OK, and then the remote access tool was installed. So very simple, phishing email, got that done. In that demo, we used actually the invite to the workshop. We infected the PDF. So that kind of hit home what that was all about. So that particular demo last year was slightly complex, held together in some parts by sticky tape. So what we wanted to do was get a quite solid demo that we could repeatedly show. So maybe like any developer would do, we went out and looked for some nicer tools. So we found Dark Comet, which was nice and friendly, so we're using it. So lots of options available. We chose 2 of them. Okay, so maybe your major bingo tick-off here is Ukraine. So Judith already talked somewhat about this already. So I'm not going to go too much into the detail of this, other than to maybe flag up some things that are relevant for our scenario. So the initial attack vector for this seems to have been emails. So I think the scenario was that there were government cuts in Ukraine, which Ukraine itself is maybe politically not in a good place at the moment. So staff at some of these DSOs were sent out emails with Excel spreadsheets that said, check here if you're going to get fired, basically. So from a social engineering point of view, that's a very good way of getting somebody to click and open that file. So once that file was opened, those systems were infected. We have various information about that maybe 10% or so in a company, if you send out a blast of these kinds of emails, about 10% of people will open them, possibly give away details. So that is a really high risk. So that's the method that we're going to use in our demonstration, is sending people a realistic looking email that they're likely, some of them, to click on. So Black Energy appears to have been the dropper. So Black Energy we met before in 2011. It's kind of evolved over time. So this version 3 Black Energy has different modules that are available as part of it. Some mystery around what the actual end attack was in terms of the operation and the link to the SCADA system. But certainly there seems to have been evidence that in the R&D department, people were sitting at their monitors and suddenly the mouse would be moving around. So the attackers seem to have infected those machines and saw that something was going on. So at that point, probably somebody outside was having a go and seeing what they could do. So probably they were observing the system, figuring out what was going on over some sort of period of time, working out what the system functions are, working out what they could do to have an impact on the system itself. So again, that's the kind of thing that we're looking at in our demo. And the important part, I guess, from this is, from our perspective, from our little part of the project, isn't so much the aRAT itself or the tool that's used to get there, but the end, the kind of the warhead, what the payload does in terms of attacking the SCADA system. So again, German steel plant, spear phishing attack, login credentials were obtained. Not a lot of information out there about this particular attack, but it seems that there was real damage caused. Possibly attackers had technical expertise. There's some discussion about maybe they didn't intend for the damage to occur, but whether the damage was deliberate from an attacker or an accident by an attacker, in the end, if you're the owner of the plant, the damage has occurred. So the takeaway message from the bingo is that it was a cyber attack, but in the end there was a physical consequence. So in the steel mill, a physical consequence. In Ukraine, a physical consequence. So what we're interested in is what is the physical consequence in the demo site at AIT when we look at photovoltaic installations. So this is a brief kind of snapshot of what the PV testbed looks like at AIT. So we'll start off down here talking about the protocol we're using. So IEC 61850 is a large, all-encompassing protocol, kind of a silver bullet, solves everyone's problems. So we're looking at a specific part of it, MMS protocol, which is used in this case to provide communications between a gateway to the inverter and the SCADA system, the HMI that is controlling certain functions of the PV inverter. So although this is PV simulator over on the left-hand side, what it actually is electrical simulator simulating input into the inverter itself. So it's a real inverter, produces real output. So it takes DC from the PV panel and outputs AC. So there are various ways that you can control that from the SCADA system itself. So over the network, you can set things like the power output, reactive power, and control voltage, and things like that. So the device we're looking at is a Fronius inverter. So here it is sitting on a chair beside Paul's dog, Jack. So we have a version of that in the lab. It's not connected to physical power inputs in the lab. It's a special version that is basically simulates the power going in. But the communication side is real, and the effect is exactly the same as it would be if the electrical power was connected. So what we wanted to do was set about seeing what trouble we could cause if we had access to that network. So that's our specific implementation. So what we're trying to do is map the attacks that we've seen before to kind of generic network and see how our solar system would kind of map to that and then carry out an attack. So there's lots of nice stuff around here. So Judith talked about some of the kind of analysis of what a system looks like. Some of the AIT guys and the front offer guys have posters talking about kind of generic kind of overview of what steps an attack can compose. But what we want to do as part of the project is to do a demonstration of a real attack. So part of our remit is not just to do the kind of academic analysis, which is good, but to kind of get the physical demonstrator out there and raise some discussion and awareness. So this is our generic kind of simplified network model, quite simplified. So we have in the internet somewhere, we have an attacker. We've here labeled an attacker controller and attacker's web server. So often an attacker will deploy their phishing emails, and they'll have compromised a web server of some other service, nothing to do with this attack. And it'll be that compromised web server that will then be used to actually kind of be the channel to the rat. So there's a bit of rerouting and obfuscation of what's actually the attacker's kind of location. So the network below you can consider as, say, a distribution system operator or something like that. Typical setup would be they maybe have an enterprise network, back office, R&D department, something like that. And then down in the SCADA domain, we have a network that can include things like a historian, could have PLCs in there, and in this case we've got a client that is connected down to the physical layer where the PV inverter is. So quite commonly, you'll have some sort of connection back to the office network, whether it's for R&D purposes, to get information from the historian. It could be firewalls, the firewall could be vulnerable. There are lots of different paths and different configurations, but we'll stick with this as a generic example. So in the demo, we'll show you upstairs the various steps. I'll go through them kind of here in a generic sense to kind of prepare you for what's about to happen upstairs. So upstairs is quite interactive, and we'll show you what's going on, but this is the kind of template that we're working from. So phishing email goes to the office network, like we talked about in Ukraine. So we get this email that says you must update your OPC server. Okay, so some people might do that, kind of looks genuine. This happens to look like, I think, Paul Murdoch, who's part of the Spark Consortium, which also is good, good social engineering. So this is a simple and often successful way of doing an attack. This is just one way of doing it. So somehow, some exploit, it could be a macro in Word, it could be an infected PDF. So once that rat has been installed by the unwitting user, in this case, the rat itself will communicate back out to the web server that's under the attacker's control. It will communicate out, establish a connection, and you'll see upstairs very quickly on the attacker's own controller, which is communicating with the web server, bing, somebody else has been infected, come and do stuff. Okay, so upstairs you'll see Dark Comet, plugx was the Chinese writing one. Okay, so at that point the attacker owns a PC in the enterprise network. So at that stage they'll carry out reconnaissance of some type. So they'll probably see what's going on in that PC. Is there something useful they can get from that? You'll see upstairs that, as I mentioned, it's a remote access tool as well as a Trojan. So basically it can act like a desktop viewer, so you can see exactly what's going on. You can go in and look at whatever you want, just like a remote desktop. So you could find credentials, email access, something like that, so that would be a quite simple path through. You could also carry out more reconnaissance, scanning the network for other vulnerable hosts or services if you don't get something useful here. But basically feel your way around the system and see if you can find something that's maybe closer to the physical layer if that's your target. So in the demo, we're going to show you that there's access to this historian. So this is a web-based historian as an example. So it lets the genuine user do genuine things on the SCADA network. But in this case, it's got a vulnerability. So lots of vulnerabilities out there, well known. This is a well-known one for this particular software. So we're able to exploit that particular web server that hosts the historian. And we gain access to it. So we're going from the attacker into the office network, and we now have remote access down into the SCADA network. So at that point, that particular exploit allows you remote shell access to a Linux box. So in this case, we're dealing with a Linux machine. So in our previous example in Cork a year ago, we used Metasploit with a plugin to cause some effect in the lower network. That would be quite a big package. So what you would do is you'd download that directly from the web server. But since then, we've refined it. It's a short, reasonably short Perl script. Encompasses all the stuff that we need to carry out the attack. So probably like any attacker, we've over time perfected our attack a little bit. It's become smaller, more difficult to detect. But basically what happens is that's downloaded, and that allows us to carry out a directed attack against the IEC protocol. So as part of that package, what we can do is sniff the traffic. So probably this is what an attacker would do, see what's going on. So they might not be familiar with the protocol, but if they watch enough traffic, they could figure out what's going on, what fields are changing, and what changes are made at what time of day. They might be able to figure out from open source publications, for example, the Fronius, there might be some information out there about what the PV functions are, and try and play with those. So in our case, what we do is we intercept and modify genuine communications. So the various ways you can do this. So one of them is you can wait for a command to go from the server, or from the client to the server, or you can basically inject at another time. So to kind of keep it more hidden, we're taking in one packet that's genuine, changing it, and sending it back out. So with this particular PV system, we're able to modify a specific thing that's called the maximum power limit. The effect of that is to change the output of the inverter. So for example, we can change it if the operator wants it to go to 100% output. We can say, don't do that, change it to 40, and it changes to 40. But then what the operator sees on their screen is everything's at 100, everything looks good. But out in the field, it isn't. The other thing we found was after below a certain threshold, the device itself would actually shut down. So you can shut down the device remotely just with that one field. So maybe talk a bit upstairs about what the maximum power limit is and how it can be used for control of the wider grid. But for now, just think of it as interfering and turning off devices without the operator knowing. So the scenario I've talked through is using the aRAT to do many things. There are multiple stages in the multi-stage attack, and at each stage we had a number of options. So I described in Cork we did it one way, here we're doing it another way. At every stage there are well-known vulnerabilities. We're just looking at some of them. But at the end is the bit that we're concerned with, which is the inherent vulnerabilities in this particular SCADA protocol and many other. And what can the IDS do in that bottom network to try and mitigate those effects? So some brief observations. Control systems are being specifically targeted. So you'll notice I haven't mentioned Stuxnet. Why is that? It's because we have all these other great examples now. So these systems are being targeted. It's no longer, well, Stuxnet could happen here, could happen there. These things are happening. So the attackers are gathering knowledge or obtaining somewhere else knowledge about systems, about the underlying control systems, about the underlying physical systems, and they're not script kiddies. Okay, so they're motivated, well-skilled people out there doing these sorts of things. And the trajectory does seem to be towards selective, tailored attacks. So we need to, as a project, we're trying to do this, better understand the physical consequences of those attacks in our system, and develop and embed some resilience against those attacks. So over time, we've seen kind of proprietary closed standards move towards a more open approach. This is taken from a paper in 2007. So I've tried to think, okay, that's the last 4 decades. What is this decade about? So I reckon this decade is where previously open but obscure protocols are no longer obscure. Basically, this stuff is out there, people know about it, and attackers are using this information. So security by obscurity particularly is completely invalid. Okay, so that's my part. So I'll hand over to BooJoong now. As I said, we'll keep the questions to the lab, it'll be a bit more interactive in smaller groups. So BooJoong will talk now, and then we'll tell you how to get up to the lab and do that.
So I'm BooJoong. So I'm research fellow here in CSIT, so working with Kieran and mostly spending time on analyzing the traffic from our testbed and find out what can we do to attack and to detect those attacks. So objectives for the SCADA ideas. Lack of security in the protocol standard for smart grid system. For example, I650 for this project. So no one cares about the security when they design the standard. So there are many opportunity for the attacker to play around in this system to build on unsecure the standard. Also, NIS recommends we should do something more about security for these systems. Backup. So our aims are so combining the knowledge on the system and find out how to monitor the application layer data for better intrusion detection system, not only looking at the network layer side in terms of the general ICT networks. So for this, we need to analyze those protocols, so how to verify, how to conduct some statement analysis for higher levels of detection mechanism, and some start from the whitelisting as well. And maybe in the future we can develop, or because we are going to, we can develop some anomaly detections. And also we are looking at the collaborative work between the other partners for supporting the resilient control from the ideas. So not only detecting something, but also we do some resilient control to recover from the attack, to reduce the damage or to save it. So this slide shows some high-level concept of our ideas. So, the attacks becoming expert since they are starting to study about in the underlying system to conduct more dangerous attack to the system. So it's becoming dangerous and hard to detect by simple detection mechanism. So we can divide attacks into some categories, but two big group would be the known attacks or unknown attacks. If we know some attack already, we can develop some signatures or some stateful rules to identify those behavior in the network side or in the component side. But always attacker find out some new ways, some other ways, some different way, some difficult way to find out. So we need to be able to prepare those kind of attacks as well. So we are looking at those multiple stage or multi-attribute SCADA ideas to protect our system in a high view. And also this mechanism is connected to the resilient control to have further reaction from the detection. So now I'm going through the detection mechanism in our SCADA ideas one by one, but shortly. So whitelist is kind of reservation. So when you have reservation to the restaurant, you can get it, right? If you don't, you are not, maybe you should wait. But they will not, we can block or drop the packet if that is not on our list. In terms of the device try to connect some other devices or some special activities from device to device. It might, if those actions or some connection are not allowed in our view, we can decline those. So this is the whitelist. It's very simple detection mechanism in the ideas. So for this, we had to know what kind of machines or what kind of action can be done by the machines before we develop those mechanisms. So if there is no information about that, we cannot build this one. And the signature is also good at detection of the known attacks. So in network perspective, we can monitor the traffic itself, the packet itself. So we can see the contents inside the packet to find out some known malicious strings or behavior in the packet itself. So this is an example of signature. It's hard to see, but you can see some hexadecimal numbers on there. So it can be directly compared with the data binary. So we can identify some known attacks from the network side. We can also specify some IP addresses on there and put numbers. But the shortcoming of those detection mechanisms is that it's just looking at just one single packet. We just investigate one single activities on the network side. We don't see any other. We need to consider some multi-stage attacks, right? So we need to be able to see the packets from other times to find out some relationship between those packets, to find out some high-level attacks. So that is why we develop some other stateful analysis mechanism in our SCADA ideas. So the critical state in the system is not only about one single action, as I mentioned. It comes with the different actions. So we need to be able to store some status of device to find out some deviation from the status. So for this, we need to analyze the system first as something like risk assessment or device analysis to build up the critical state information. And in terms of the SCADA ideas, we need to be able to see the contents itself, not only some IP address or some length of the packet, but we have to see the content itself from the application layer information to find out, for example, in our demo scenario, we are looking at the maximum power limit. So we need to be able to see and extract that information from the traffic. So, and the critical state can be combined by some other actions as well. So something like this kind of rules can be derived from the system description or configuration or some risk output of risk assessment. So for the ideas, we need to implement some deep protocol analysis to get the application layer information. So those, this is a screenshot from some network analysis tool, which is Wireshark. So you can see inside of the packet showing all the detailed information. So this is the MMS packet for IS650. On our, this is not from our testbed, but this is same protocol and same communication protocol, MMS and IS650. So you can see what kind of commands are requested and what data being used and what values are there. So it means attacker can see those information as well, not only the ideas, not the good guys. So what we have to do is decode those information in the ideas and store this information and watch and monitor the device behavior to find out any suspicious or known attacks. And we also, I will talk later that part. So for the stateful analysis, this is one example of our stateful analysis mechanism. So once we get the packet, we need to decode application layer protocol and inspect contents and the state information. And we will have to update state to further to next investigation, incoming other traffics. And the on the right side, left side, this process is for rule matching process for write request, because the packet has different types of data and different types of structure. Then the investigation process should be different for different types of requests. So for the write request, we have to see what kind of domain and attribute you are trying to override, and what attribute, what values you are trying to change. So the kind of inspection process should be conducted. In other case, we need to have some other process. So we develop different inspection process for different types of requests or responses. And also, the stateful analysis is not, we provide the stateful analysis mechanism by allowing to correlate for different, between the rules. Then we can compare the status, what kind of device, what status of device are now. Then we can decide some other action based on those state information, not only looking at single packets. And next one is the anomaly detection, which is not fully developed right now. This is one from the other research at 2014. So what they do is collecting the traffic information from internet layer to the application layer. Then they apply those information to some clustering algorithm to build up some models, some profiles of normal behavior of devices. And they can generate some profiles. Then based on that, they compare with those profiles against these. They compare the incoming traffic, the future traffic, with the predefined, pre-generated the profiles, and find out some deviation, some outliers from those profiles. They detect as some suspicious, not some suspicious behavior. The one of the drawback of this approach is that they don't use any application information. They do in this MMS part, but they don't decode it. They just use some byte information or length or packet rate. So we are looking at the application layer information. So it will be a different point for our future anomaly detection in SCADA IDS. So this slide shows the entire overview of our SCADA IDS. So we have 5 different approaches, which is included one. This is the one I haven't mentioned yet. So this is for protocol violation. So somehow attacker, at the first time, attacker might not know about the system or protocols. So they try to pause the system. They just try to send some random packet. They might try to do that. So in that case, the attacker will have some violation in terms of the protocol side. So we need to add another detection mechanism here as well for that case. So whitelist generation, signature generation, protocol violation rule generation, and stateful rule generation, and machine learning. So those are our defense mechanism in depth. And those process should be done before you run the SCADA IDS with those information. So system configuration, because this SCADA IDS should be customized to each system. So we need system configuration to generate some whitelist and the stateful rules. And for the signature, we can use third-party signature, like digital bonds from the snort. We can use the third-party signature database because our IDS is able to accept those standard style of the signature. And from the protocol standard, for example, I650 and MMS, we can generate those many information. And from our history of the system, we can build up some anomaly detection. So with the Whitelist signature, some set rules and models, profiles, we can identify incoming network traffic. And we can find out known attacks or some suspicious behavior based on those capabilities and show the display the information on the web interface. We are using the open source visualization tool, which is ELK, Elasticsearch and Logostage Kibana. So showing those information in the web interface, you can see the alert information as well as the metadata, some system status to monitor the device. So yeah, cut to the chase. This monitoring capability can be done by HMI, right? You can see all we are trying to do is then monitor the device, monitor the system. But you can do monitoring by HMI, right? That's why we are using the HMI or some control devices to monitor the underlying field. But the point is that as we show the man-in-the-middle attacks can be manipulate those traffic between HMI or controller with the devices, then how can you trust the data from the device? But in the network side, there is no way to delete or hide from the IDS, so we will see all the traffic, even though they are doing some man-in-the-middle attack. Because in the network side, the network device will transfer all the packet to the IDS. Then we can see all the information. So that is it could be it could be another sensor for the legislation control and high-level detection mechanism. So that is why we also collecting metadata, not only alert information, and show those information in the our interface. So the one last slide, I guess. This is about the IDS. IDS 3 is over now. So this is about our new attacker. Actually, it's more simple one than the MITM attack, man-in-the-middle attack modules. So this is a scanner, MMS scanner. So on the left side, you can see some mapping between I650 object and MMS object. So if your system is developed by I650 and using MMS, so we can scan your system using those tools. Yeah, we assume that we already found some MMS device here, and they are using default port numbers because they never change it. And then we can just spread broadcasting the MMS packet to each devices and ask what kind of information do you have it. Yeah, they have the get name list. So list, they are asking list what information you are handling it. They provide the way to ask what are you doing, what do you have. So we can just send it. Then the device will tell us, oh, I have this information. And then we can ask it, so what value do you have it? Then they will respond, oh, this value is this. Then we can run about the devices, keep sending those messages. And also interesting part is the part access. So actually, in one very well-known library for I650, give this access as optional. But it still can be included for operation region to operate the device in remotely, to update the system description or device description, to change the parts. It's very dangerous one. Attacker can just delete the files, and when they reboot it, the device will not act correctly. So it tells us another reason why we have to prepare not only ideas. So this is from me. So this time to rock. So for the demo, let's go to observe, and maybe some of us will stay for the posters, right?